Hello, my lovely Algebra 1 students. Today you are going to be finding the zeros of a quadratic function and taking notes from this video. So it's really important that as you are listening to the notes and following along on your note sheet, that you pause the video if you ever need to catch up writing anything down, or you go back and rewind and replay the video if you feel like there's a concept that you missed. Also, as you're taking notes, jot down any questions that you have anywhere on your notes page so that we can be sure that we go over it when I am back in class tomorrow. All right, let's get started. So the zeros are the x-intercepts in the real number system that are the points on a parabola that when substituted into an equation will make f of x or y equal 0. So we know that the zeros are the x value that when you plug it into your equation, if you were to simplify, it would make your y equal 0. So there are 4 different ways that we're going to be solving for the zeros of a quadratic function in the rest of this unit. The first is finding zeros from graphing, which is what we'll be doing a little bit today. The second, oh look at that, our old friend factoring. The third, another familiar face completing the square. And the fourth, which some of you may have heard of before, is called the quadratic formula. So today we're going to get started on finding zeros from graphing. In our first example, we're going to look at the graphs below and identify the zeros. So just a recall, last part of the unit when we were talking about the zeros, we referenced them in terms of the x-intercepts. And the x-intercept is where our graph crosses the x-axis. So that's where our graph is crossing this axis right here. So this blue curve, this parabola, is crossing the x-axis at 2 points. Our first one is at the ordered pair of -4, 0. So the 0 is the x value of the x-intercept. So our 0 is x equals -4. That represents a solution because if we were to substitute that into the equation that corresponds to this graph, our y value would be 0. So we can take that 0 and write it as its x-intercept, which is -4, 0. Our second 0 is where our graph crosses the x-axis. It's not quite at 1, so we're going to say that is at 0.8, 0. So the 0 is the x value of the x-intercept, which we're saying x is approximately 0.8. We don't know for sure if that's what it is, so that's why we use the approximately symbol. And our x-intercept would be 0.8, 0. In our second example, again, we're looking for where this blue curve crosses the x-axis. So our first point is at 1, 0. So the 0 is our x value of the x-intercept, so x equals 1. The x-intercept is 1, 0. Our second is not quite at 7, so we're going to say we have, so we're going to have 6.9, 0. Which means, and because we're not exactly sure if it's at 6.9, we're going to say our 0 is x is approximately 6.9, which makes its x-intercept 6.9, 0. In the next example, it looks like our parabola only crosses the x-axis at 1 point, and that 1 point is -2, 0. So the 0 is the x value of the x-intercept at x equals -2. Our x-intercept is -2, 0. And then in our fourth example, we have a parabola that doesn't ever cross the x-axis. So that blue curve never crosses this axis. So what that means is that we don't have any zeros, but we're going to introduce a new way of saying this. We're going to say Never crossing the x-axis means that we have no real zeros. And what we mean by real is that we're working within the real number system. There is another number system called the imaginary number system, but you guys will learn more about that when you take AAT. So for x-intercepts, because it doesn't cross the x-axis at all, we would say none. Now we're going to work on identifying the zeros given a table instead of given a picture of a graph. So in our first table, we are going to see where our f of x is equal to 0. So I have a little picture up at the top that we're just going to sketch out to really demonstrate what we mean by finding a 0 from a table. So I drew a little coordinate plane and a rough sketch of a parabola. Well, our 0, as we went over last time, is where f of x, or y, is equal to 0. So that means if we're looking at our table, we're looking for where the f of x column or the y column, so this column here, is going to have a 0 as its value. Another way that we can look is we can notice that our graph crosses the x-axis. It either goes from a positive y value to a negative y value, or a negative y value to a positive y value. What that means is that if we have a table where we can't see where f of x is equal to 0, we're going to look for where the f of x values change from either positive to negative or negative to positive. What that means is that the graph must have crossed the x-axis if it went from above the x-axis, so somewhere up here, to below the x-axis somewhere down here. So if our f of x values change from positive to negative or negative to positive, then we must have crossed through the x-axis at some point. So in our first example, let's start by looking if we can find where f of x is equal to 0. So my first part that I see is I have 0 where my x value is 2. So that means that my 0 is 2. My second is where we have an x value of 3. So my two zeros for this parabola are x equals 2 and x equals 3. We can have either no real zeros, 1 0, or 2 zeros. We'll never have more than that. So if we have our 2 zeros, then those are all the only 2 zeros that we'll find in our table. In the second example, again, I'm looking for where f of x is equal to 0, so I find my first one at my 0 of x equals negative 5. My second is where f of x is equal to 0, where x is equal to 1. So my two zeros are x equals negative 5 and x is equal to 1. In the third example, I scan my f of x column. I can see where f of x is equal to 0, which means that my 0 is x equals 4. What I'm going to notice now is because I only had 1 0, is I'm going to try and look for any changes from positive to negative or negative to positive in the f of x values. So I filled in plus signs or positive signs for all those values in the f of x column. If my f of x column were to change from positive to negative or negative to positive, then that means I would have crossed the x-axis. However, in this case, none of my f of x values ever change to be negative. So I know that my 0 is x equals 4. But what does that mean that my graph looks like? Well, let's draw a quick sketch. So my 0 is at 4, 0. That means that my 0 is on the x-axis, and since all the other values are positive, that means that the vertex is actually the only 0 that's on the x-axis. So there's only 1 0. Okay, in example 5, we're quickly going to scan the f of x column and look to see if f of x equals 0 anywhere. But as we can see, none of those values equal 0. Okay, so now we're going to look for changes from positive to negative or negative to positive. So far, everything in f of x is positive. So what does that mean? Let's draw a quick sketch. It means that my parabola is above the x-axis and never will touch the x-axis or even cross the x-axis to go into the negatives. So my entire parabola is sitting above the x-axis. So what does that mean for my zeros? It means that I have no real zeros. For number 6, let's do a scan and look for where f of x is equal to 0. So we do have one 0 easily identifiable where x is equal to 5. For the other 0, let's look to find changes in where our f of x values go from positive to negative. I did have one spot where we went from a positive 0.8 to a negative 0.6. So what does that mean? That means that my graph must have crossed through the x-axis if it went from positive to negative. So where is our 0? It's between the x values of 3 and 4. So that means that I have one 0 at x equals negative 5. And my second 0 is going to be between the x values of x equals 3 and x equals 4. I don't know exactly where it's crossing the x-axis from this table. I only know that it will happen somewhere between the values of 3 and 4. For our last example, we do a quick scan of f of x. There are no values that equal 0, so we'll check for where our graph changes from positive to negative. So it looks like we have two spots where our f of x values change from positive to negative. So the first is in between the x values of negative 2 and negative 1. That means that our graph will cross through the x-axis somewhere between negative 2 and negative 1. Our second 0 must be between, and I'm using BTWN to abbreviate between, the x values of 2 and 3. So our second would be between x equals 2 and x equals 3. So let's summarize. How did we find all these zeros? So how did we find the zeros in problems 1 and 2? Well, we found the zeros by looking where f of x is equal to 0. That was easily identifiable for us. How did we find the zeros in problem, that should be problem 6 and problem 7, so fix that. So how did we find those zeros? Well, we simply looked for where f of x changes from positive to negative or negative to positive. That means that our graph must have crossed the x-axis somewhere between two x values. How many zeros were there in problem 3? In problem 3, there's only one 0 because we found where f of x was equal to 0 and the other values were never negative. So that means that our only 0 is the vertex and it was on the x-axis. And finally, how many zeros were there in problem 4, which we should change to number 5? How did you determine those number of zeros? So there are no real zeros in number 5 because f of x never changed from positive to negative, so it never changed signs. And there's no spot where f of x equals 0. So that means that the graph never touches the x-axis. So that's all we have for the notes for today. Please make sure that you jot down any questions that you have so that we can clear up those questions in class tomorrow. Thanks for watching.